This video will be over the basic concept of a function. Before I can get into that, I want to go over some basic definitions. Alright, a relation is a correspondence between two sets. If x and y are elements in these sets, then you could say that x corresponds to y, or y depends on x. We can display relations several different ways. The first type would be by an equation. For example, y equals 3x minus 1. That shows a relationship between x and y. In this instance, you say x is the input and y is the output. I'm sure you've heard these terms before. Another way you could show a relation is by ordered pairs. What this means that if there's a relationship between x and y, you can show it as just an ordered pair, x, y, like you've been dealing with since you were in 8th grade. Another way you can display a relation is by mappings. If you have a set of states and another set with the number of representatives for those states in Congress. And suppose we have the states Alaska, Arizona, California, Colorado, Florida, and then I abbreviated North Dakota, ND at the bottom. Suppose you have the number of representatives 1, 7, 8, 25, and 53. Now, Alaska maps to 1, Arizona maps to 8, California maps to 53, Colorado maps to 7, Florida maps to 25, and North Dakota also maps to 1. There's another example of a mapping. You could also show it as an ordered pair if you wanted, which I guess I'll do now since I already mentioned it. Alright, you say Alaska, 1, abbreviated Arizona, 8, California, 53. And I'm too lazy to write out the rest, but I think you get the picture. Now I'll go over the exact definition of a function. A function is just the relation between two sets x and y such that each element of x maps to only one element of y. Alright, so it might look like this. Notice how each element of x is mapping to only one element of y. Or it could look like this. So if you have all these elements of x, all these elements of y, each one could map to a different element. In both these, x is called the domain, and y is called the range. And the elements of x are what we call the independent variables, and y is what we call dependent. Alright, the elements of y to which the elements of x map are called the image of the element x, or they're also called, or the value of the function at x. Alright, I have a mapping here. Of different gas stations and the price per gallon. I want to know, is it a function? Now, if you notice, each value of our independent set, or our x set, which would be the gas station, each element maps to only one y value, which would be the price per gallon. So, yes, it is a function. Alright, let's see if the following relations are functions. If you look at A, the points 1, 4, 2, 5, 3, 6, and 4, 7, usually to tell if the relations are functions in ordered pairs, you look to see if the x value repeats. If it does not repeat, then that means, yes, it is a function. The reason being is that if the x value did repeat, then that means the x value would map to two different y values. And if you look here, let me close that parentheses. The x values do not repeat here, so it would be yes. But if you look here, the x value -3 maps to two different y values, positive 8 and positive 9, so the answer would be no. Here's another example. Determine if y equals 2x minus 5 is a function. Right. Ignoring the fact that you should know that that's a linear equation and thus is a function, if you were to look strictly at the equation and use what I've told you so far and nothing else, you would notice that if you plug in a value of x, you only get one y value for every x value you plug in, so the answer would be yes. Alright, here's another example. Determine if x squared plus y squared equals 1 defines y as a value of x. Alright, let's solve it for y and see what we get. So you should get that y squared is equal to 1 minus x squared. So since we're solving for a variable, you would need to take the positive or negative square root. Now if you notice, for each x value you plug in, you would get two separate values of y. That means each x maps to more than one y value from -1 to +1. So the answer would be no. Alright, now we're going to go over an example of finding the values of the function. Alright, for f of x equals 2x squared minus 3x, evaluate f of 3, f of x plus f of 3, 3f of x, f of negative x, negative f of x, and f of 3x. F of 3, you just plug in 3 into x, so you should get 18 minus 9, which is 9. For part B, f of x plus f of 3, you take your f of x, which is 2x squared minus 3x, and you know f of 3 from earlier is just 9, so you add 9 to it. Alright, and for part C, 3f of x, that's equal to 3 times 2x squared minus 3x, which gives you, if you distribute, 6x squared minus 9x. And for part D, is f of negative x, which would be 2 times negative x squared minus 3 times negative x, which would be, now you have negative x being squared, so the negative would go away, so it would just be positive 2x squared. Then negative 3 times negative x would be positive 3x. Then negative f of x, part E, would just be negative, and then 2x squared minus 3x, which would be negative 2x squared plus 3x. In part F, f of 3x, which would be 2 times 3x x squared minus 3 times 3x. That'd be 2 times 3 squared, which is 9, and then x squared minus 3 times 3, which would be 9x. 2 times 9 is 18x squared minus 9x. Now we're going to go over finding the domain of the function. When finding the domain of the function, you look for any values that x cannot be, which means for fractions, what values make the denominator equal to 0? Those values are not in the domain. Also, and for square roots, or really any radical expression with an even index, what values make the discriminant negative? Now there may be other things you need to keep in mind when finding the domain, but for now we're going to focus on those two. Alright, here's an example. Find the domain of the following functions. First one is f of x equals x squared plus 5x. Second one, g of x equals 3x over x squared minus 4. Third one is h of t equals 4 minus 3t. And the fourth one, big F of x equals square root of 3x plus 12 over x minus 5. Alright. For the first one, x squared plus 5x. Now there's no rational expression, no x's on the bottom of the denominator, no radical expressions. So the domain, you could just write it as all real numbers. Part B, g of x equals 3x over x squared minus 4. If you notice, we have a rational expression, so we need to take figure out what values make the denominator equal to 0. If you solve it for x, you find out x squared is equal to 4, and the values of x that would make the denominator equal to 0 would be positive or negative 2. So you could write the domain as all reals, except that x cannot equal positive or negative 2. Right, and for h of t equals 4 minus 3t. Alright, notice we have a radical here, and since it's a square root, we need to make sure that the stuff that's underneath the discriminant is greater than or equal to 0. So, if we solve it for t, negative 3t must be greater than or equal to 4. So if you divide by negative t, or negative 3 I mean, t must be greater than or equal to, actually it should be less than or equal to, because remember we divide by a negative, so you flip the sign. Be less than or equal to negative 4/3. So our domain is just all the values less than negative 4/3. And for the fourth one, we have both a rational expression and a radical. So you have to figure out both which values make the denominator equal to 0, which would just be 5. Then you also figure out what values would keep the discriminant positive. So if you take 3x plus 12 and set greater than or equal to 0, then solve, you have 3x is greater than negative 12, which means x must be greater than negative 4. So the domain would be all x values greater than or equal to negative 4, except that x cannot equal 5. Because If we plugged in 5, that would make the denominator equal to 0. Alright, now I'm going to go over some notation with you. If you see something f plus g of x, that means you're just adding two functions, f of x and g of x. If you see f minus g of x, that means you're subtracting. If you see f times g of x, that means you're multiplying. And if you see a rational f over g of x, that means you're dividing. Assuming, of course, that the function g is not the constant function, just 0. Given, alright, here's an example. Given f of x equals 1 over x plus 2 and g of x equals x over x minus 1, determine the following four problems: f plus g of x, f minus g of x, f times g of x, and f divided by g of x. Also, find the domains of these functions after you add, subtract, multiply, or divide. Alright, for the first part, f plus g of x, that'd be 1 over x plus 2 plus x over x minus 1. So now, if you determine x multiply both sides by x minus 1, actually that side would be multiplied by x minus 2 on top and bottom, because you want a common denominator. So it'd be x minus 1 times x plus 2 rather. So it'd be x minus 1 times 1 plus x times x plus 2. Right, I think I have everything correct now. X plus 2 over x plus 2 right here. Because those should cancel out, the x minus 1 should cancel out, so we're good. So now, let's go ahead and simplify this. You have 1 times x minus 1, which is x minus 1, plus, distribute the x, you have x squared plus 2x. Then you have x minus 1 times x plus 2. And now on the numerator you have x plus 2x, which would be 3x, minus 1, and then you have x squared. So you have x squared plus 3x minus 1 all over x minus 1 times x plus 2. Alright, and if we want to state the domain, that would just be all real numbers, except that x cannot equal positive 1 or negative 2. Because if you plug in positive 1 or negative 2, that would make those would make the denominator equivalent to 0. Alright, for part B, f minus g of x, it's actually very similar to the first part, 1 over x plus 2 minus x over x minus 1. Multiplied by this one by x minus 1 on the top and bottom, this one by x plus 2. So you have 1 times x minus 1, which would be x minus 1, and then minus x times x plus 2. Then you have x minus 1 times x plus 2. Then you have x minus 1, and then if you distribute the minus x, you have minus x squared and then minus 2x, all over x minus 1 times x plus 2. Then you have I have no idea what I just did. Let me erase that real quick. Well, let me erase it, but I got it off to the corner so it's out of the way. So now we can combine like terms, minus 2x and then positive x. That would be minus x minus 1 and then minus x squared, all over x minus 1 times x plus 2. And there's your answer. Because to my knowledge, we can't simplify that anymore. And once again, the domain would be all real numbers, except that x cannot equal positive 1 or negative 2. For the same reason as in part A. Now for part C, f times g of x, that would just be 1 over x plus 2 times x over x minus 1. So you have 1 times x, which is x, all over x plus 2 times x minus 1. You notice the denominator is still the same. And that's our function. Our domain would actually still be the same. Domain of all real numbers, except that x cannot equal positive 1 or negative 2. Alright, f of g of x, that's equal to, remember, you just divide function f 1 over x plus 2 over the function g, which would be x over x minus 1. Now if you notice, we're dividing by a fraction, so you flip and multiply. So you have x minus 1 all over x times x plus 2. And the domain would be all real numbers, except that the functions, or the values that make the denominator 0 in this case would just be negative 2, or if you plug in 0 to x, this first value here would become 0, which would make the denominator 0. So the values of x that are not in our domain would be negative 2 and 0.